Okay. So moving on to the IMS. Okay. Now, the IMS is the IP multimedia subsystem, and is the main architecture for operators that wants to offer end user services in the packet domain that need more from the network than just IP transport. So, currently what we are offering for most part of the packet core network, what we are offering is just IP transport to be able to transmit and receive packets from the internet and then send packets to the internet. Okay, that is what we are doing, the packet core network. But then the IMS network gives us an edge whereby we can provide some services within the core network so that the subscriber doesn't go all the way to the internet. Examples of these services are gaming services, are streaming services, are any service that we wouldn't need to go all the way to the internet, like voice conference, video conferencing, like this e-meeting, like using this kind of app, Teams app. We can have, let's say, in MTN network or Airtel Tigo network, our own household made e-meeting or video conferencing network, which doesn't require the use of us using Teams or Zoom or other e-meeting apps. So here the IMS network makes it possible for us to be able to have these kinds of services in the same network without going all the way to the internet or using the over-the-top applications such as Skype, Zoom, WhatsApp, Teams, and then other applications. So basically, that is what the IMS network is. The IMS network is made up of four main nodes. We have the ICSCF, we have the PCSCF, and then we have the SCSCF. Okay, what are these nodes? The PCSCF is the node which is closer to the subscriber. So in every network, we have the access part of the network. The access part of the network is what connects the user to the network. The first point of contact of the user is the access part of the network. Now, the first point of contact of the IMS network is the PCSCF. The meaning of the acronym is Proxy Call Session Control Function. Proxy Call Session Control Function. Proxy meaning the first intermediary, okay? So the first intermediary of the core of the IMS network from the point of the user is the PCSCF. Then we have the ICSCF, which does interrogate the HSS for subscriber location, okay? So all the ICSCF does, which the name clearly says, I standing for interrogating call session control function. This node is what makes it possible for me to be able to request the location of the subscriber that I'm trying to call in the IMS network. He will retrieve the information from the HSS, and then the HSS would get the information from that particular subscriber's 7 CSCF. Where that subscriber is located, it will retrieve that information, give it to the ICSCF, to the PCSCF, so that the PCSCF will be able to connect to the SCSCF. Okay, now, what is the SCSCF? The SCSCF is the 7 call session control function. It is the main node in the IMS network, right? Which handles the call setup, handles towards the MMTel application server, MTAS. It handles the subscriber location, authentication of the subscriber, and all those aspects are being managed by the SCSCF. So we have three types of CSCFs. We have the PCSCF, which is the proxy node towards the access. We have the ICSCF, which interrogates the IHSS. Then we have the 7 CSCF, which is the main node handling the authentication, the registration, the call establishment of the subscriber. So basically, if you are asked the question, what are the 4 main nodes in the HSS? It's just these 3 nodes. It's the ICSCF, the SCSCF, the PCSCF, and then the HSS. The MMTEL AS or the MTAS is just an adjoining node, which gives us the functionalities that would require, such as the gaming, such as the video conferencing, the voice calling, and all those things will be handled in this the multimedia telephony. Just a moment. Looks like somebody is coming. Okay. Now we go into the detailed IMS network. Now, the IMS network is made up of 4 main parts. Okay. We have the part towards the access. We have the part which is the core, the IMS core. We have the part towards other networks called the NNI. And then we have the part towards the application service. So these are the 4 main parts of the IMS network. We have the UNI, that's the user to network interface. We have the IMS core. We have the NNI, that is network to network supports and functions. We have the application server functions. Now, in the access part of the network, let me show you. In the access part of the network, the main node is the PCSCF, which I've already mentioned. There are other nodes such as the ATCF, and then the CBGF, and then the ATGW, which we'll talk about in the coming slides. Then in the core network, we have the CSCF, which is the ICSCF, the SCSCF, the ECSCF, and then also a functionality we call the breakout gateway control function, or the BGCF. Okay, we will talk about those nodes in the coming slides. Then examples of nodes that exist in the NNI are the IBCF and then the MGCF. So these are main nodes that exist in the NNI part of the IMS network. Then nodes that exist in the application servers are what I mentioned before. We have the MMTEL AS, we have the scheduled conference AS, and then other nodes which would mention or we'll talk about in the coming slides. Okay, so let's pay very close attention. The first slide just gave us a basis architecture, which comprises of the 4 main nodes. The next slide gives us the detailed architecture, but here we've broken the architecture into 4 main parts. We have the access. An example of an access is the PCSCF. We have the IMS core. An example of the IMS core is the ICSCF, the SCSCF. The ECSCF is the emergency CSCF, and then we have the border breakout gateway control function. It's also an example of a node that exists in the CSCF. We will talk about that clear in the coming slides. And then we have the NNI part, which comprises of the IBC CF. Then we have the application part, which an example of that node is the MMTEL AS, and then the conferencing application server. So these are the four main parts of the detailed architecture. And then previously we looked at the four main nodes in the basic architecture. Now, what is the IMS? What is the PCSCF? Okay, so as I mentioned, the PCSCF is the first point of contact between the IMS terminal and then the IMS network. So what it does is that it's allocated to the IMS terminal during registration and does not change during the registration period. It includes the security, authentication related functions, charging, signaling, compression, policy decision functions, etc. The PCSCF also includes the RAC-F functionality for the fixed access and the ATCF for the VoLTE and then SRVCC. So what is talking about is that in the PCSCF functionality, we have the node which connects to the fixed. So if I want to be able to connect to the fixed network, right? So this is the fixed network. If I want to be able to connect to the fixed network, I need what we call the RAC CF, this node, right? So this node is what connects to the PCSCF in order to be able to connect to the broadband access or the fixed network. Now, the node which connects to the VoLTE or the 3GPP network, such as the EPC network, the LTE network, is the ATCF, okay? The ATCF is an aspect of the PCSCF. So in a network, you will not find a standalone ATCF, you will not find a standalone PCSCF. You will find a node called the SBG, the session border controller or the session border gateway. And in this SBG, you have these different aspects of functionality being implemented. Okay, so the SBG is the node which sits at the access part of the network. And in the SBG, you have these different nodes such as the PCSCF, the ATCF, the CBGF, which connects to the access part of the fixed network, you know. So these are the different networks and then how they are implemented. You know, we cannot have all these. We'll have a lot of nodes in the IMS network, but then here we are talking about the functionalities, how they are implemented. They are implemented most of the time in one node, okay, one physical node, and in that physical node is broken down into these different aspects. And in the case of the access network or the UNI part of the network, the node that is used is this SBG or the session border controller. In the SBG, you would find the PCSCF, you find the ATCF, you find the CBGF. You find these different nodes that are all of them located in the same SBG. Okay, so PCSCF is one of the access nodes. One node is the ICSCF, which I've already mentioned. The ICSCF is a SIP stateless proxy located at the edge of the IMS domain. Okay, it's involved in the registration and terminating requests. The address of the ICE is listed in the DNS records of the domain. Okay, now what is this guy and what is his function? So as I mentioned before, the ICSCF is the node which interrogates the HSS. As you can see, has an interface to the SLF and HSS, right? In the case whereby you would want to register a subscriber or you would want to terminate requests, this is the work of the ICSCF. Now, in the IMS network, we have what we call the stateful proxy nodes, and then we have the stateless proxy nodes. When we say stateful proxy, what does it mean? Stateful nodes are nodes that are able to keep record of the subscriber location, right? And the subscriber details whenever a call or registration is being set up. Now, a stateless proxy is a node which does not keep a record of the subscriber's location and the information about the subscriber. So an example of a stateless proxy node is an ICSCF. An example of a stateful proxy node in the IMS network is the PCSCF and the SCSCF. So going back to this slide, the ICSCF, when you are asked a question, what can you give an example of a stateless proxy? The answer is going to be an ICSCF, because an ICSCF, all it does is to interrogate HSS, get information, give to proxy. Proxy uses it to connect to the SCSCF. That's it. It does not remember the information it requested. It doesn't keep record of that information. When it does the request, it's done. These two nodes, that's the PCSCF and then the SCSCF, are stateful proxy nodes, because what they do is that they keep the state of the subscriber in their records. So they know where the subscriber is, and then they also have information about the subscriber details, what the subscriber is able to do, the services the subscriber is allowed, he can terminate, he can start, and all those things. That information is stored in the stateful proxies such as the PCSCF and then the SCSCF. So this was just a divergence to be able to explain what this stateless proxy, and then the stateful proxy, what it means. Now, the SCSCF is the central node of the signaling plane, okay? So the SIP7 or SIP routing performs session control as well. It is the SIP registrar, maintains a binding between the user location, IP address of the user terminal, and the public user identity, creates and stores user contact information. So here, as I told you, the SCSCF is a what? A stateful proxy. So what does it do? It keeps the user location information, and then is also able to map the user to its identity. Okay, so here we have a very an example of a stateful proxy, right? Which is the SCSCF. It also interfaces the HSS and then the SLF for authentication and then user profiles. Now, in a case whereby you have more than one HSS in a network, you have to go through a node which is called the SLF. The SLF is just like a load balancer, which directs the traffic towards which HSS to talk to. Okay, so some networks have only one HSS, then you might not need an SLF. Okay, so but in the case whereby you have more than one HSS, you need an SLF to be able to direct where the call has to go to, or which HSS the SCSCF would have to communicate with. Okay. Performs user service triggering based on the user specific information downloaded at registration. The SCSCF invokes application service for end user service handling. All the SIP signaling related to an IMS will be traversed the allocated SCSCF. You understand? So here, as you can see, the SCSCF is a central node connecting to the HSS or the SLF, connecting to other nodes. Another example of a node it connects to is the PCSCF. Another node on the application layer it connects to is the SIP application server, or the MTEL or the MTAS. Okay. Also connecting to the ICSCF. So here we find the SCSCF connecting to different aspects of the network, because it's a central node in the IMS. The HSS and then the SLF, as I already mentioned, right? HSS is the database, just like the HLR. We've already seen the HSS in the EPC network, right? But this HSS pre-existed the EPC network. It was just borrowed into the EPC network. This IMS network had been in existence for a long time, but at a point in time, they didn't know what to use it for. You understand? So HSS has always been around, but then when we migrated from the GPRS to the EPC network, that was when we saw the introduction of HSS. But HSS had always been in the IMS network. So as I mentioned, if the SLF is a node which is able to connect to the particular HSS that the SCSCF would like to, communicate with. You understand? So in the case whereby you have more than one HSS, then you would have an SLF in operation. The HSS implements the diameter protocol, which we'll talk about, not the SIP. So the communication between these nodes, that is between the SCSCF and then the ICSCF towards the HSS, is the diameter. For most of the time, you find that the communication between the IMS network is based on SIP protocol, right? It's based on SIP protocol. But then for this special communication between the S and then the ICSCF towards the HSS and then towards the SLF, you will find what we call the diameter protocol, which we'll talk about more. The proxy gateway handles the provisioning interface and then the provisioning logic between the HSS front end and then the CUDB. Now, this takes me to a concept which I think is very key for me to explain at this time. Initially, we had an HLR, one node, which was handling the logic of how the call was supposed to be handled, like handling, storing the database, making sure that the MS is being served, the SCSCF is being served, right? But in this new architecture, just like how we had the MSC broken down into the MSC server and then the media gateway, we had the SGSN broken down into the MME and then the SGW. Now we have the HLR or the HSS broken down into the part which handles the application logic of the core. And then we also have the part which stores the information of the database. It stores the information proper. In 3GPP terms, we call that the UDR. Okay, that's the Unified Data Register. But in some vendors, they call that UDR the CUDB, or some other network will have a different, some other vendors would have a different name. Okay, but in some main vendors in the telecom space, they call their UDR the part which just stores the information, just like what we are seeing here. So here we have the part which just stores the information called the UDR or the CUDB. Okay, then we have the part which handles the logic of what subscriber they are requesting for, and then how to be able to send the information, like the routing of the subscriber if he's in another MSC and all that information, the location of the subscriber. It's being handled in the HSS or the HLR. So here you find these HSS, HLR called the HSS front end, and then the HLR front end. Front end being the fact that they only handle the front end aspect of the call session, but then the database storage or the repository of the information of the subscriber information and all that is stored in the CUDB. Now, in order for us to be able to have subscribers in the network, we need to provision those subscribers, and this provisioning is being handled by another node called the PG. That's the provisioning gateway. Okay, so this is how the database has also evolved, whereby we had one node which was handling everything. Now we have the node that is thinking for the database. It's all it does is it handles the logic of the database. It doesn't store the database information. It doesn't know anything. It just handles the logic. If the MSC wants, or the CSCF, SCSCF, or ICSCF wants information about the subscriber, it communicates with another node called the back-end node or the UDR, or in some vendors calling it the CUDB.
to be able to retrieve